So the next problem is like this. There are two bars, A, B, and B, C. C is a pin joint, and A is connected to a bar which slides in this collar, you could say. Okay. And for the angles are not given in a straightforward way. They're given as these rise over runs, so that's okay. That's what we're going to use. What else is given? VA is given, velocity of A, and it is in this direction. Let me draw the arrow. So this is the direction of VA, which is given. We're asked to find VB, omega AB, omega BC, and omega system is the angular velocity of the system is omega AB. Okay, so what we're going to do first is draw the find the center of instantaneous rotation. Now if A moves like this in this direction, then B is going to go up, right? B is going to go up, so we need to draw a perpendicular line out, and we need to do the same perpendicular from here, perpendicular to VA. So from here I'm going to draw that. Okay, so that's our instantaneous center. Okay, we'll call that point O. Okay, now the way we're going to go about solving this problem is we're going to find again OB and OA. Once we know OB and OA, we're going to use the formula V equals R omega to find all of these things. Okay, the only thing is finding OB and OA requires a little bit of trigonometry. That's the only tedious part in this question. Otherwise, the actual angular velocity formulas are pretty easy, as we've seen in the problems before. Okay, now how do we go about finding this OB and OA? Let's see. First, look at triangle ABD. Okay, triangle AB, AB, I forgot to draw something here. I need to draw A. Okay. So look at triangle ABD. So D, we're drawing AD such that AD is perpendicular to OB. Okay. We're splitting triangle AOB into two right triangles. Okay. We're splitting it into two right triangles, and so that we can find OD and DB, and that way we can find OB. And also the triangle AOD will help us find AO. Okay. All right, so in this triangle, now we know that if this angle is 5/12, right, is given by that ratio, then we can say that this would be 12/5. Okay, because OA is perpendicular to VA, right? And if the angle is of VA is if the tangent is 5/12, if the theta is 5/12, then then it is going to be the same angle for this triangle triangle DAO. Okay, so in other words, imagine this L shape, and that is making a certain angle with the horizontal. Okay, it's making an angle with the horizontal. Okay, that angle. Okay, now if you take this L and bring and rotate this L, this in yellow highlight, by this angle theta, then this angle, then it will close this angle, right? If this short leg of this L merges with this pink line, with the horizontal, then the long end of this L, long arm of this L, will merge with the vertical line, right? So that's why these two angles would be the same. All right, let me go ahead and erase these. Okay, that's why that angle, and you can also convert it into degrees if you like, but we can also leave it like this. I think it's easier to leave it like this and use the ratios. Okay, so in this triangle, right, in this triangle A B D, right, ABD, here, in this triangle ABD, again we have a similar situation where the slope is given, right? The rise over run is given. So in this triangle, if we look at sine theta, right, this is 4, 3. Okay. If we say sine theta, 4, 3. Let me do this another way. Let me, instead of giving that, I'm going to do it like this. Okay. So that'll be 5. That'll be 4. I'm going to make that 3. Okay. So sine theta would be 3/5. Okay. Sine theta would be 3/5. So that is why, so the slope of this is 4, and here, let me go in a little bit of detail. I'm sure you know all of this, but I want to make it as clear as possible. Okay, so the hypotenuse itself is 5, but that is given as 4 and 3. Okay, because this is rise over run. The slope of this hypotenuse is given by, this is the slope, so rise 4 over run 3. So the horizontal part, which is here, that is 3, and the vertical part is 4. Okay, so that's why sine theta is 3/5. Okay, so 3/5. Now if you look at it in the context of this triangle ABD here, then that comes to BD, right? BD, sine theta is BD over AB, right? AB, which is actually AB is given as 1.5. Sorry, forgot to mention that. So this is 1.5. Okay? 1.5. So from this you can find BD, that is equal to 0.9 meters. Similarly, cosine theta, it would be 4/5, that is equal to AD over 1.5. That means AD is equal to 1.2 meters. So we have AD and BD. BD will be useful for us because in finding OB. All right. Now let's look at this other triangle AOD, right? We're looking at this triangle. Right? We're looking at AOD. Okay? in triangle AOD, similarly, we have, say here, let's say alpha. Cosine alpha is AD over AO, right? And cosine alpha is also equal, so this relationship we can say 12 over 13 is equal to 1.2 over AD. Let me see again. So here alpha, so cosine alpha is OD AO. Okay, so cosine alpha is 12 over 13. How did we get that? So let me draw. So this is AOD, and we're saying this is so this is 12 over 5. Okay, so that's the slope. Now so cosine alpha cosine alpha would be so if this is, let's say if this is 5, right, this would be 12, this would be 13. So these are not the actual dimensions, but going by the slope, say if OD is 5 and if AD is 12, then AO would be 13. Okay, so cosine alpha would always be in this ratio. Okay, out of this, what do we know? We know AD. How do we know AD? We just found out. Okay, so 1.2. So obviously AO, when you plug in the numbers, you'll get 1.3. Okay, now we found AO, we also need to find OD, right? So how can we find OD? Let's use the tan alpha. Tan alpha would be OD over AD. Okay, tan alpha ratio in this triangle would be 5 over 12. 5 over 12, and OD is what we need to find, and AD is, we just found, we know AD is 1.2. So OD would be 0.5. Okay, so now we know all of these dimensions. We know OD, we know BD, right? OD was 0.5, so this is 0.5. Maybe I should use a different color. Okay. So this is 0.5. BD is 0.9. OA or AO is 1.3. These are the numbers we need because those are the radii V equals R omega. Now let's go ahead and apply that. Okay, V equals R omega, so VA would be equal to OA or AO times omega AB. VA equals this radius OA times omega of A, omega of so omega AB. Now omega AB is what we need to find, right? Omega AB is what we need to find. So we know VA is 2.6, it's given. OA we just found out 1.3. So omega AB would be equal to 2 radians per second. Okay, 2 radians per second. Now if we look at VB is equal to R, so VB is equal to R omega AB. R in this case would be for joint B, for the point B, the radius is this, right? And VB is this. So if we know, if we can get the angular velocity using VB and this radius. Now this radius here is sum of these two. Okay, radius is VB equals omega AB times the radius OB, right? Because this radius, because we're calling this O as the center of instantaneous rotation, right? So the radius is what? From that point to the center, about this center, this entire thing AB is rotating. It is appearing to rotate about that center O. So from V equals R omega, the angular velocity of AB, this entire link, or in the previous problems we have called it, like, you know, we have seen ladder problems, the entire link or ladder seems to be rotating about this point O, and VB is the velocity at B. Okay, and OB is the radius of rotation. OB and omega AB we just found out is 2. Okay, and OB is 0.5 plus 0.9 times 2, so that's what, 2.8 radians per second. Okay, so we know VB again R omega. Okay, so if we need to find the angular velocity of BC, then we need to use the radius, right? We need to use the radius BC, right? Okay, so this radius was also given 1.2. All right, so BC times omega BC. So but VB we already know is 2.8, BC is 1.2, that's given. So omega BC, so omega BC would be 2.8 over 1.2, you get about 2.33 radians per second. Okay, so to recap, what did we do? We found, first we located the center of instantaneous rotation, then we wanted to find these distances, so we drew this vertical line AD, split this triangle into two right triangles, use these angles. If this ratio using this slope form seems confusing, then you can always convert that into angle, right? So say tan theta, equals 4 over 3, right? And then theta is tan inverse 4 over 3. Find that angle, and you can use just angles instead of these ratios. It works the same. So here, instead of having sine theta equals 3 over 5, you'll find this angle, right? You'll find the angle, and when you find the sine of that angle, you'll get 3 over 5, which is 0.6. Okay, so that's why instead of going over it, instead of converting into angle and getting the sine of that angle, they just give you something like this, so we can use that readily. Okay, So we use that to find these distances. We found this from this triangle. We found this and this from this triangle. That way we found the radius AO, and then we found the radius BO. And then for AB, angular velocity of AB is OA. If you multiply linear velocity of A, times this radius, linear velocity of A divided by this radius gives the angular velocity of this arm, right? V equals R omega. So velocity of that point, the radius is the distance from that point to the center of instantaneous rotation, gives you the angular velocity of that arm that it is connected to. Same way, it is the same arm that is connected to B, so the angular velocity of that arm is equal to VB divided by, angular velocity of that arm is equal to VB divided by that radius OB. Okay, so that way we found VB, we found omega AB, and then for omega BC, same thing. We know the radius, we know the distance, and we know angular velocity of B, right? We know this, we know the arm, so we can find the angular velocity of BC.